Good afternoon, everyone, and thanks for the organizer for giving me this opportunity. Before I start with, I would like to bring a difference, probably what you have seen. The previous three speakers who have talked to you about more from the HR perspective, they are from the HR angle. They would have given you a lot of insights on the employability and the skills and all that part. I will probably get it more from my experience of how I have gone through in training people on the engineering part of it when they come in from the colleges, and then when they move on, what kind of challenges they face, and after 5 years, 10 years kind of things when we call it as a middle career concerns or a dilemma, what they do and what we should as a society do to really help our next generation to face the future of the work. It's our culture in our company to start any meeting with a HSE note. HSE stands for Health, Safety and Environment. So probably this is definitely whenever whoever is working, obviously you have stress, so maybe it's good to talk about stress. This data is for UK, but it could be different, may not be too much different for us. 75 to 90% of all doctor visits are related to stress. I'm sure you all agree with me, right? So what all the stress does on all these parts, heart rate goes up, BP, you have sugar problems, whatever we can talk about, we basically link it to the stress, right? Some easy ways, and don't just look at only the fourth part. Fourth part is talking about eat it up, but please look into that. It is not eating up everything, but only the greens or vegetables which will help you in enriching your vitamins and things like that, right? So please take care of your stress, that's very important. With that brief on the HSE part of it, I would like to bring up the statistics. Again, you have been in this discussion from the morning. The numbers could be slightly plus minus, but we all talk about the same thing. We have very, very less percentage of people, we call it as employable, and that too for the current industry scenario. We are not talking about the future, we are talking about the current. Right? The question we have to ask ourselves is, are we really that bad? Are we saying that only 10% or less than 10% of us is really, the product what we make are really employable and everybody else is not employable? Further dividing that into multiple different things like starting from software or a mechanical engineering or the core engineering and moving on to the business analyst or non-technical roles. In every role, this is is what we are seeing. We are seeing about 10% is where we are employable and everybody else is non-employable. I am not talking here as an industrialist, I'm not talking here as an academician, I'm not talking here as a student, but if you look at yourself in this society, are we in an ecosystem where we produce 90% not right at the first time? We call it a first time of first pass yield or whatever in the different terminologies in the industry. Are we living in a society where we can produce 90% not so right at the first time and still we want to be a kind of a developing country to developed country and want to be the number one in the world in all this? Is there something wrong in us? So I was just trying to look at, again, based on the experience, what are the reasons and how do we put them up? Are we learning, whatever we learn, are we putting them into use? If I look at from a student angle, I am a mechanical engineer by studies, and after my mechanical engineering, if I go and do a software program development, maybe for financial applications or for infrastructure applications, am I putting whatever I have learned into use? That's the first part of it. And the second part of it, if we are doing that, are we learning enough? The content of whatever we learned during our college days, is that sufficient enough for the industry? Because we are not here to produce people who are going to reinvent the wheel again and again. We want people to start from wherever it is today to make an incremental change. What does it mean? We want people who have learned whatever is there today, who have a good conceptual understanding of what is there today, so that they can move on to the next step. That means the depth of the learning, that's critical. That is the second part of it. And then the third part of it, Are we teaching the relevant things, right? For example, if we talk about mechanical engineering, again, I kind of bring an example from my own area. I may talk about creating a drawing using a mini drafter, but is it really needed for this current industry? Probably we don't even need a drawing. We are getting into additive manufacturing, right? So are we teaching the right thing for our students? So if you put these three questions, the first question, who is responsible? As a student, if I am choosing to learn, say, civil engineering, I should plan to work in that area. So that's a student responsibility or a parent responsibility. As a faculty, the second point, are we giving enough importance in teaching them the right thing and ensuring that we have the right assessment process? A lot of the people, when we talk outside, so we get a feeling like, okay, because even though he is learning a mechanical or anything other than the software engineering related subject, majority of the placement is related to software. So we tend to be a little bit kind of lenient on what he learns other than the software, because our intentions are good. We want him to be employable. So we try to kind of help him in reducing the burden on what he is anyway not going to use. In that process, we teach him less, right? And the third part, again, curriculum. How frequently we change our curriculum. We still continue to teach using the mini drafters. We still continue to teach the partial differential equations or something which is kind of a very, very basic, which you should have studied in 11th standard, 12th standard, and get into more of a complex numbers and the Fourier transforms and things like that in your engineering days. Are we really adapting to the changes by benchmarking ourselves with the current level what we are, right? So in my opinion, as I said, in an ecosystem, the students, faculty, industry, curriculum, everywhere, we need to really have a kind of a responsibility to look into this so that we will be able to have a better platform for our next generation to look for a suitable work, right? Maybe some of my industrial friends may not like this slide, but are we as an industry encouraging the inefficiency in the system? I work for Infosys, maybe I can bring in that name, if Lakshmi can excuse me. I go to a campus, I have 1,000 people to scrutinize, I do an aptitude test, and I conduct an interview, and then I select people. I do not understand whether he is a mechanical, civil, whatever subject he learns. I look at his aptitude, whether he is good enough. Because that's what I want. I know I can manage him, no problem. But when we do that, repeatedly, the first year student himself thinks that if I am going to go to software company, even at the entry level of that company, I am not going to be tested on what I have learned in engineering. And I am not going to be using it in my entire life. Why should I pain myself in learning it? Everybody has the same question, right? So we don't learn it. And on top of it, as I said, if I am a mechanical engineering faculty, and if the student asks me the same question, I think, yeah, you are right. Probably I will have this 10 set of questions. If you can read this, one of these questions will come and you will be passed. You can go ahead, prepare for rapid test, go ahead. So we kind of dilute the content. And companies, because we have attritions, because we are kind of moving the people up many times, and we are putting them into different areas. We had our, one of the previous speakers talked about, we will have a request today, next week we need to have people who are ready to join the project. So what we look at, we have the process, we want to be process driven. We will have set up standard work instructions, standard operating procedures. Anybody comes in having a basic knowledge, we'll do step 1, 2, 3, 4, we'll be able to deliver it. Very good for the project. But just think of the person who comes in with a little knowledge on what he is doing and a very standard instruction list of this is what he should do, and have very less time to understand why he is doing that. Down the line, 5 years, what happens to him? He is a person who does not have neither his engineering skills nor a very good understanding of what he is doing currently, because he is focused on doing particular thing in a particular way without questioning it much, right? And in this mode, he becomes unemployable any further, right? So it's not only for the people who are coming into the industry, who are in the industry after 5 years, 6 years, 7 years, if you go and ask any of the placement consultants, they will say that if there are people with 3 years, 5 years experience, they are the hot cake. The moment somebody crosses 10 years, he is like 30 plus on the marriage market. He loses his value, right? So that's exactly what's happening. So are we as an industry, when we are looking at more and more efficiency in what we do, are we as an industry also creating a problem in the society in encouraging efficiency in some other form? We have to think about ourselves. I would put it this way. Are we really buying for the content or the container? We want somebody who will be adaptable to my way of working and unlearn everything. These are the words we use, right? Unlearn everything what you have learned. You have to come in here, adapt to whatever I say, and then do it this way. You are fantastic. But are we asking for the content, the person who, what knowledge he has, or whatever capability he brings in? Are we looking for some body with some software mind, right? So my perception, we are not equipping our engineers. Right? If it is wrong, I'll be happy. But we are not equipping our engineers for the future. Why I say this? This is, highlighted by many of the earlier speakers. I don't really have to emphasis on this further. From the gradual evolution, what was happening earlier, if you look at the graph on the right side, what you're talking about, if you look at from 1400, 1500s, the years, like we took a lot of time to invent something new. But then we are on a very, very steep curve, hyperbolic curve. Every other day something is changing. It's not an incremental change. In fact, this is the other way of explaining the same scenario. We are talking about each of this wave. If you look at on the y-axis, what we are capturing is the amount of innovation, the newness what you bring in. On the x-axis, you are having the time, how much it takes to innovate something new. You are kind of shrinking the time period, but you are also increasing the amount of change what you bring in. So the person who was doing, say, iron or water power or mechanization is no more relevant for the second wave or third wave, because there you need is something very different capability to look for. Similarly, now probably they had all of their lifetime to change, 30, 40 years. So somebody comes in, joins a company, industry, he has a surety that till the end of his workable life, he has something to work on. Today, if you ask any of our colleagues whether they work on a technology which can last for 5 years, I don't think many can give an answer yes. They'll say probably yes, but we don't know, right? So we have to be continuously looking for something new. So the waves are shorter, and the durations and the heights are kind of incrementing a lot. This again a point which was highlighted by some of our previous speakers. If you really look at the delta change in the new product development or innovation, or different words what we can call it, we can put them in 4 different baskets. First one is the very high in the process change, very high in the product change. We could call it as the R&D, and then the breakthrough technologies, and then the next generation platform, and then the enhancement, right? I believe most of the people whom we are producing today from our education institutes are kind of fitting in for the 4th category. They can work on what is there, they can help in doing some kind of incremental changes in what is there, but if you have to look for them to work on 1, 2, and 3, we really have to look at something different. It's not really where we are equipping them. Again, the same point put in different flavors. When I saw this in some of the colleges, when I go and interact with the students and the faculty, I was really happy to see that they're not limiting the students doing the theory classes and the practical classes in the laboratory, but they help the students in participating in building their own cars and going for the competition across India and winning the prizes. Really good. They get a knowledge and the first-hand experience of the manufacturing. That's good. But then somebody is telling that in 2020 a car is going to be like that. Our previous speakers were talking about autonomous vehicles, right? It's going to be maybe 10-20% mechanical, 40-50% electrical, electronics, and the rest with connected technologies, GPS, so on and so forth. So if you are an automobile faculty, if you are running a mechanical engineering faculty in your college, how do you structure the curriculum? Should we really talk about only gear trains, power trains, engines, or should we talk about connected cars? Should we talk about electric vehicle, should we talk about autonomous vehicle? So the change what we are embracing today as academic institutions, probably in my opinion, is not really sufficient enough. We have to kind of pull up our socks and run a little more. Again, the same thing in a computer industry performs. Again, during our college days, if we saw something about the improvement in the computers, maybe the clock speed is bigger, the memory is bigger, the computer size is coming smaller and smaller. Now, I think we are talking about converting all the hardwares into softwares. Even at home, we don't want to have the plug points as a hardware unit. We want to convert them as software so that you can have a metering. You know how much of power is being consumed in a particular room or a particular right or a refrigerator and on time, off time. So many things we wanted to mandate there, right? So we are kind of converting everything from hardware to software. So there's nothing like a hardware engineering itself is there. Probably I will give a little more in-depth understanding of with a case study. This is for the people who are from the mechanical engineering background. In the earlier days, we used to prepare the drawing, which is taken for the patent shop or the manufacturing shop to create the pieces. And the drawings are manually created. So it would have taken X amount of effort. So consider the horizontal scale what you have is the effort that is required to do that activity. Over the years, we have started using the computers. We have started doing a 2D drawing, 3D models, and then the parametric models. We brought in some kind of efficiency improvement, again doing library-based modeling. In all these 4-5 categories, we were looking at how do we do things faster. We are reproducing the same thing. We are not doing anything different in the end product, but we want to do it faster, right? So that's what is happening in the first phase, where we kind of improve the efficiency. Then came in a situation where somebody says, no, I can automate this. I don't really have to have an engineer doing this, have a draftsman doing this. I can get this done by somebody who is not even an engineer. Then automation comes in. Then somebody says, anyway, after design, you need to have a verification. So I will build the verification into it. That's good. And then somebody says, whatever knowledge the company has built in developing this program, I will have the software embedded in your program. So when somebody does the design, it will directly check whether design is acceptable or not, so that you don't have to go through the process of failure. And very good. It's all an improvement what we are doing in the product development. And then the functional verification. So you run your calculations to see whether the structure can withstand the particular loads what you talk about or not. So that you are doing. And then, okay, I have designed it, I have to manufacture it, so why should I have an interface in between, a human interface in between? Directly put that program for the manufacturing, so there is a CNC program machine which can do it. That comes in. And then recently we are talking about additive manufacturing. We don't even have to have a metal to be kind of machined or all that. So you can kind of keep layer by layer additive manufacturing. We all know what additive manufacturing is, right? In this process, what we are doing, over the years, the effort what has taken this many days to do a particular activity, you need just this much. Now the person who is here, if he is a mechanical engineer who is very, very good in doing a drawing, engineering drawing creation, we have been every year appreciating him and doing, yeah, you are doing good, you have not made any mistake, every year you are kind of improving your efficiency, till a particular point, and then we tell him, okay boss, sorry, we don't need your service anymore, you can go look at something else. And for him, he doesn't know anything more than that. And that is happening in this industry, and it is happening in many other industries as well. Right? We had a photo film, we don't need a photo film, we need a coil here, but just think of the family, people who were there, the Hindustan photo films, maybe in Ooty. What are they doing now? We don't know. We have a printing press, offset printing press, where manually you had all the things to be done. I mean, it's now converted into electric, computerized printing. Now that printing unit goes useless. So in this process, what are we doing? We have lot of people who become unemployable. So as an industry, what we really have to look at, when we talk about efficiency, specialization, so we had few of our previous speakers spoke about specialization. Please look at the specialization or the efficiency part with a little bit of pinch of salt. Make sure that when we do that, we have enough time and effort available for the individuals to spend on enriching their knowledge in something else so that they stay relevant to the industry. Otherwise, we become very weak as a society. And especially for the academicians, we don't want to really run your master's level program at a bachelor's level. In fact, during my days, the first year of engineering is common for all the branches. We all study the same thing because whether it is physics or chemistry or maths, it's all relevant, and it is very relevant for every engineering discipline because you want to have the strong fundamentals. Now probably we are kind of saying that, no, this is not required for a computer engineer, this is not required for a mechanical engineer, we are specializing it. Please revisit that, because very early stage of specialization means we have a very, very narrow base that could really topple the structure very quickly. The base should be broad and strong, then let's start building the depth, right, as we go along. Otherwise, the specialization at a very early stage could become very, very weak. Please look into that part. I don't think we have to go through this. We've spoken about this. I would like to close my talk with this. The first two parts, this is the slide which we spoke about earlier. The first two things, that is what a student can do, what a faculty can do, can really increase the efficiency of what we are doing, but making sure that we are learning the relevant thing, which is as a curriculum, as a system, what we have to kind of introduce in our education is what will improve the effectiveness. And the change should happen from the effectiveness part and then start improving the efficiency instead of just looking at the efficiency part. In that way, I think putting together all our brains together, we will be having no doubt in making sure our future, we will give a right future for the students to have the work, which is definitely they will not have, should not have a thinking whether they are going to have the work for 5 years, 10 years. They should have the confidence that they are going to have the work for a lifetime. But I would like to close with the point what Lakshmi mentioned about, if there is one thing which we have to instill in our younger brains, that is the culture of continuous learning. If an engineer comes out of the college thinking that he is going to have a continuous learning throughout this period of his work, if that is the one thing which you can ensure it is there in his life, I am sure he is fit for the future of the work. Thank you.